there. Let's take a look at a nice linear programming question here. We want to buy some kitchen cabinets. We realize that cabinet X expenses $10 for every unit, obliges 6 square feet of floor space, and holds 8 cubic feet of records. Cabinet Y costs $20 for each unit, obliges 8 square feet for floor space, and holds 12 cubic feet for storage. You've been given $140 for this buy. You don't have to need that much, or you don't have to use that much. The workspace has has space for close to 72 square feet of cabinets. What number of each model would it be advisable to purchase, keeping in mind the end goal is to boost storage volume? Okay, so the thing on that one, when they're talking about the volume, we're looking at that last piece for each of those types of units. That is the cubic feet, right? We're going to use the R programming language to solve this, and we're going to write out our functions and our constraints. As mentioned, we want to maximize storage volume. So I'm going to write this as z is equal to 8x plus 12y. Now we're going to set up our constraint. So each unit of X costs $10, each unit of Y costs $20, and we can spend up to and including 140. Then for the square feet, we have 6X plus 8Y is less than or equal to 72. Okay, so that's what we're going to start out with. Now let's turn this into an R linear programming problem. I'm going to use the LP solve package. So you're going to, if you don't already have it, you're going to install LP solve and put it, wherever you typically put that. And you're going to load the library LP solve. All right, so let's take a look at our objective function and the left-hand side of our constraints statements. So the objective is going to be the 8 and the 12. The constraint matrix, that is the left-hand side, that's going to be your 10 and 20 from the first row, 6 and 8 from the second row. You're going to have 2 columns, and you're going to have by row equal to true, if you're familiar with putting in your matrices. Now, the second value, or I should say sets of value, you're going to put in the directions of the constraints, and those are your inequality symbols. So they're both less than or equal to. And then finally, the right-hand side of your constraints were your 140 and your 72. Okay, now we're going to solve our model. We're going to use the max on the objective function. Sorry, you're going to use the LP function. You're going to use max on your objective. There's the name of your objective, constraint matrix, constraint directions, constraint right-hand side, and just set that compute.sense equal to true. All right, now you're going to print the solution, and this will tell you if you've succeeded or not. And yes, you have. And your value is going to be 100. So that actually represents 100 cubic feet of storage. Now let's see what else we have in that LP solution object. So we have all kind of stuff in there. We have seen that the value of the objective function, that is the objective, is 100. There's your 100 square feet, sorry, my fault, cubic feet of storage. Now let's take a look at individual components. So what I just did a real quick and dirty cat statement. The total cubic feet of storage is, and then I put in that objective value with X and Y values of LP solution, $ solution. So that lists out the value for the X and the Y. So I'm going to buy 8 units of X and 3 units of Y. So when we look at everything in the end, we see that we have exactly $140 for our cost. We have exactly 72 square feet for our floor space. And as promised, the storage volume is 100 cubic feet. All right, hope this helps. Bye.